Hey everyone, Mr. Random speaking here. It's been a while since I made one of these videos, but hey, we're back. Couple quick things. I'm going to stop numbering the videos all in order for every single topic. Instead, I'm going to number them by unit. So this is the first video in our next chapter, matrices, or the plural of matrix. So this is chapter 4 in the book. This video will be quick. Basically, what is a matrix? No, I'm sorry, it has nothing to do with Keanu Reeves. But anyways, we're going to learn about what it is, what they use for math, and other stuff like that. So, let's get going. So, what is a matrix? Well, let's take that red pill and learn the truth. And what if I told you that this was it? That's all a matrix is. It's an array of numbers. That could also be a spreadsheet. If you had a spreadsheet like on an Excel file and you just had a bunch of numbers for different things, you could turn it into a matrix. It could also be something like just a grid. So a spreadsheet, a grid, an array of numbers, basically something like this. 7, -1, 0. I'm just making up numbers for no reason whatsoever. This right here is a matrix. And more importantly, this would be a 2 by 3 matrix. 2 rows and 3 columns. This is all a matrix is. It's a way to store information quickly, and usually each row and column stands for something. So we already have some data, and I want to use a matrix to show this. So what you see, and this is very timely as you can tell, is I compared Jay Cutler and Aaron Rodgers, two quarterbacks, their quarterback rating. If you don't know football, it's very simple. Higher numbers are better. And you see a difference. Year, 2012, 2013, 2014. See a pattern? Every year, much, much better Aaron Rodgers is. But this I can turn into a matrix. Basically, I can just take the data right here. This would be a matrix. Just an array of numbers. This would be a 3 by 2 matrix. I just have, the rows show years and the columns show the person. So I'll just put people there. So each thing stands for something different. So let's look at just some simpler matrices and learn how to call out dimensions. But before I do that, just to reiterate, you can take any data that's organized like this, right, nice and neat, and just take the actual numbers. Each one of these points, all 6 of them, these are terms in the matrix. So all 6 of these parts are each terms, so the whole entire grid itself, all 6 members, that would be a matrix. Okay, let's move on. So a little definition of how to define dimensions, so like how big matrix is. The size is just how many terms there are. So an n by m matrix has n rows and m columns. So rows are this, right? Columns are just like columns building up and down. So if I have something like this, let's go 1, 2, 3, 4, 5, 6. This one has 2 rows and 3 columns. This would be a 2 by 3. What about this one here? -0, that was dumb. 1, -8, 0. This would be 3 rows, 1 column. This would be a 3 by 1. And this last one here has 4 rows. That's an R. 1, 2, 3, 4. And it has 2 columns. This would be a 2 by 4 matrix. So make sure you can do that. Make sure you can call out a matrix based on the dimensions. So how many rows, how many columns. So rows first, columns second. So here I have one more matrix. This one has 1, 2, 3 rows and 1, 2, 3 columns. this would be a 3 by 3 matrix, because I have 3 of each. So let's call out some terms. So let's say I want to know, oh, by the way, you're going to see this usually. Something like A2, 1. That doesn't mean 21, that means A2, 1. So that means second row and first column. So what term is second row and first column? Look over here. Second row, first column. That's 0. What about a, let's go 3, 2. This means third row and second column. What term would that be? Third row, second column, right there. And the first one again, second row, first column was right there. So there you go. I'm going to erase this to save space. And what would be, try this one and pause it. How about a, let's go 1, 3. So again, not A13, A1, 3. What term in this matrix would that be? If you said pi, I'll use the actual marker, then you are correct. That is the first row and the third column. So that first number corresponds to the row, and that second number corresponds to the column. So you'll be asked to find certain numbers of certain matrices. This is how you do it. We'll do more in class if you're not quite getting all of it. So last thing here, I've given you 5 matrices. For each one, tell me the dimensions. Let's look here first, the first one. How would I call out this matrix? Well, I have 2 rows and only 1 column. This is a 2 by 1. The next one, can you beat me to it? Look at it, how would you define it? We've got 2 rows and 3 columns. This means this is a 2 by 3. Hope you beat me to it. Third one, number 3, what is it? Look at it. 3 rows, 3 columns, it's a 3 by 3. Next one, number 4, 2 rows, 2 columns, this is a 2 by 2. And finally, 1 row and only 1 row and 4 columns, this is a 1 by 4. That's all I got for this video. Go on to the next one, Matrix 2. Bye, y'all.